Hi everyone, you are watching Math Tech 15. In this video, we will see the one of the most important topic of the class 12th and PUC second year, that is the inverse trigonometric function. And in this video, we will see the principal value branches along with their domains and the ranges, and we will solve some questions also. And if you recall back, we studied the trigonometric functions in the class 11th, and we studied the domains and the ranges of the trigonometric functions, and we studied the set of formulas like standard angles, allied angles, and identities, multiple angles. We study the set of formulas, and in this class 12th we will study about the inverse trigonometric function. And the inverse, this word inverse, you already heard in the previous chapter, then relations and functions. This is one of the trigonometric function. This is also functions only. Inverse exists only if it is the function is bijective. Bijective means 1 1 and onto. Okay, then only the inverse will exist. In this video we are studying the inverse trigonometric function. We are going to study here inverse trigonometric function. Is all the trigonometric functions are 1 1? Okay, let's check first that. So let's see here. This is the graph of sin x here, sin x function. Okay, now just see here, what is sin 0 value? What is sin 0? Sin 0 value is sin 0 only. What is sin pi value? That is also 0. What is sin 2 pi value? That is also 0. And what is sin minus pi? That is also 0. And sin of minus 2 pi, that is also minus 0 only. So what is this meaning? So if you take the domains as a 0, pi, if the inputs are 0, pi, 2 pi, then you will get the ranges. Output here 0 only. Sin 0 is also 0, sin pi is also 0, sin 2 pi is also 0. This is the domain, and this is the range. Is it 1 to 1 1 function? No, it's not 1 1 function. It will become as a many one function because the multiples of inputs have the same output. Then it is called as the many one function, not 1 1 function. So how it is possible to find out the how it exists inverse trigonometric function? That's the reason we will take the one part of the graph which is 1 1, which satisfies the 1 1 function. So we will take the one restricted part of this whole graph. Okay, so which one we need to select, that is the important. Okay, we have to select from 0, we should compulsory we need to include here. 0 to pi, is it possible? We have to check. Otherwise pi by 2 to minus pi by 2 to plus pi by 2, we need to check here. Just see here, if I take the restricted domain as a 0 to pi, okay, in between 0 to pi, here if whatever the some value here, 30 degree, whatever this, that this value and this value having the same y value here, so same output, we are getting the same outputs because it's coming like curve shape. So in this, if in this portion you will get the same value of y, so it's not possible to take the 0 to pi. So which one we have to take here? Restricted domain minus pi by 2 to plus pi by 2. For the different domains we have the different ranges, codomains, different outputs. So our restricted domain will become here minus pi by 2 to plus pi by 2. What is the range here? Range will come here minus 1 to 1 only. The values is coming here, y values minus 1 to 1 only. Now see here, I wrote already in the natural sin x function, what are the domain will come here? R, all the real numbers will come, and the ranges is here minus 1 to 1 only. See the graph here, see the graph, just see the graph here. Your wave is coming, it's not more than 1 and not less than minus 1. So it is in between minus 1 to 1. So range is here minus 1 to 1. What is restricted domain here? Minus pi by 2 to pi by 2. Why we took the restricted domain? Why? Because to satisfies the 1 1 condition. That's the reason. So range will come here minus 1 to 1. So now we can easily, the inverse will exist here because it satisfies the 1 1 function, injective it will satisfied. So sin inverse equals to here the inverse trigonometric function sine inverse domain is becomes here the range of the sin x, that is the -1 to 1. It will reverse. Okay, range will become here domain and domain will become here range. So sine inverse x domain will become here -1 to 1. It's a closed bracket. Why? Because it has the value -1 and it's include the -1 to 1. That's the reason. If it is include, we have to take the square bracket. So it's included -1 to 1, so it's a square bracket. And the range is here -π/2 to +π/2. It is also included, so you need to take here close bracket. This is the graph of the sine inverse x function. So here the x value and y values is interchange. That's the reason it will come looks like this type. Okay, this is the graph of sine x and this is the graph of sine inverse x. We have to take only this much part only. Why? Because it should satisfies the 1 function. That's the reason we will take the domain is here. Which one we have to take domain? Only -π/2 to +π. Hope all of you understood this one. Similarly, cos x also. What is the, see the graph of the cos x here? Graph of the cos x. So if it this is the graph of the cos x. If I take -π/2 to +π/2 means again the outputs will come same y ranges. Here in this case here the y values will come same. So in this case we have to take here restricted domain as a 0 to pi. 0 to pi. In the natural graph, what is the domain here? The domain is here R and the range will come here -1 to 1 here. -1 to 1. -1 to 1. Okay. But the restricted domain it will become here 0 to pi and range is same only -1 to 1 close bracket because -1 and 1 is included. Cos inverse x means the range changes to domain, domain changes to range. The cos inverse x graph is here. Just x and y values are interchanged. It will come vertical. The graph looks like vertical shape. Okay. Next. Hope all of you understood sin x and cos x. Next is the cosecant x. Cosecant x means this is the reciprocal of sin x. So it will come 1 by sin x. It will come 1 by sin x. In the mathematics we know the denominator should not be equals to 0. So should not be equals to 0 means the domains of the cosecant x all the real numbers except where the sign is becoming the 0. We in the previous video we saw here in the previous sin x we saw sin 0 is 0, sin pi is 0, sin 2 pi is 0, sin -pi -2 pi. So n pi is always sin of n pi is always 0. So the denominator should not be equals to 0. That's the reason the domain will become here x belongs to R, all the R, but x should not be equals to n pi. X should not be equals to n pi. And the range is here all the real numbers but not included -1 and -1 to 1. Now see here, this is the cosecant x graph here. All the real numbers will come but here -1 to 1. Exactly 1 will come and -1 will also come. That's the reason they have taken open bracket -1 to 1. But this values here it's a blank because graph the blue color it will comes like this only. All the values like more than 1 will come and less than -1 will also come. But in between 1 to -1 to 1 it won't come. Exactly 1 it will come, may come, and -1 also it may come. That's the reason we have to take here range is here R minus of -1 to 1. Now we have to select here. It's not possible if you take whole domain as the real numbers means it won't satisfy the 1 to 1 function. That's the reason we have to take restricted domain. Which one we need to take here? If I take this one blue color, this graph, if I take like this from 0 to pi, then the values will comes here, the values will repeat. The output will, for the different input, we will get the same outputs. That's the reason it's not possible. So you have to take here minus pi by 2 to plus pi by 2. So what are the ranges will come here? Same as it is. Real numbers except in minus of minus 1 to 1. Okay. So restricted domain will become here minus pi by 2 to plus pi by 2 except 0, because in the 0 no values is there. Okay, it's clearly, it's see a graph, it's not touching to the 0, that's the 0, it's a gap is there in between for 0. That's why you have to minus pi by 2 to plus pi by 2 minus of 0. The range will come here r minus of open bracket minus 1 to 1. Then cosecant inverse will exist here because it satisfies the 1 1 function. Then cosecant inverse x equals to, the domain changes to range and range changes to domain. So the domain of the cosecant inverse x is here r minus of open bracket minus 1 to 1. And what is the range here? Minus pi by 2 to plus pi by 2 except 0. So minus of 0. Similarly, secant x also. Secant x means it is the reciprocal of cos x. See here, cos pi by 2 is 0. So you have to take all the real numbers except x should not be equals to here. X should not be equals to 2n plus 1 pi by 2. Because all the pi by 2, like I will show the cos x graph here. Just see the cos x graph. Cos pi by 2 is 0. Cos 3 pi by 2 is 0. Cos 5 pi by 2 is 0. Cos minus 3 pi by 2 is 0. Cos minus 5 pi by 2 is 0. So that's the reason, because denominator should not be equals to 0. So the domain we should not take as a all the real numbers except 2n plus 1 pi by 2. Okay. Then what is the range will come here? All the real numbers minus of minus 1 to 1. I will show the graph here. See here, the values comes all the real numbers, but here just check it out. 1 is your value, output value, and minus 1 is also your, you have the output value, but in between minus 1 to 1 there is no outputs here. So that's the reason the range is all the real numbers minus of open bracket minus 1 to 1, because minus 1 and plus 1 is included in the real number. That's the reason we have to take minus 1 to open bracket minus 1 to 1. So now we have to take the restricted domain, which will become our restricted domain. If I take minus pi by 2 to plus pi by 2, for the same input we will get the same output. For the different input we will get the same outputs. That's the reason it won't come. So you have to take from 0 to pi. So the values for the different inputs we will get the different outputs. So it satisfies the 1 1 function. That's why we have to take here 0 to pi. Now see here, what is the range? The range is same. All the real numbers minus of open bracket of minus 1 to 1, because in between minus 1 to 1 there is no outputs here. That's the reason. So the domain will become here 0 to pi minus of pi by 2. In the pi by 2, in the exactly pi by 2 there is no value here. Just see here. That's the reason we have to subtract the minus pi by 2. So the range will become here all the real numbers minus of open bracket minus 1 to 1. Now secant inverse x domain will become the range of the secant x. So the domain of the secant inverse x is r minus of open bracket minus 1 to 1. What is the range here? The range is close bracket 0 to pi minus of pi by 2, because in the pi by 2 there is no value. Just see here, in the pi by 2 it's not touching here. The graph is gap in for the pi by 2 here also. So there is no domain for this one. That's the reason you have to subtract here minus pi by 2. That's the reason the range is also 0 to pi minus pi by 2. Then the graph of secant inverse x we will get like this. This is the graph of secant inverse x. Okay, in your textbook is there, you can check it out. Next is tan x. What is tan x in terms of sine and cos? It is a sine by cos x. Sine by cos x, again in the denominator its cos came, like similar like a secant x, so denominator should not be equals to 0. That's the reason the domain of the natural graph of tan x is also same as it is secant x. So all the real numbers except x is not equals to 2n plus 1 into pi by 2. So in the cos pi by 2, cos 3 pi by 2, the value will come 0. That's the reason all the real numbers except x should not be equals to 2n plus 1 pi by 2. And the range will come here, all the real numbers. All the real numbers. Now see here, all the real numbers. In the previous secant and cosecant inverse, it will showing the gap in between minus 1 to 1. But it's coming all the real numbers. Okay, so now we have to take the restricted domain. Restricted domain, it's minus pi by 2 to plus pi by 2, because in the minus pi by 2 to, for the different inputs we have the different outputs, so we have to take here minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. Again the range will come all the real numbers here. So the tan inverse x is domain is all the real numbers, and the range is here minus pi by 2 to plus pi by 2, open bracket. Why open bracket means, see here, just it's not touching to the pi by 2 and minus pi by 2, it's a gap. Next, cot x is also same as it is, but it is the definition of the in terms of cos and secant means it will come cos x divided by sin x. The denominator is here sin x, like so the domain it will comes like cosecant x only as it is. So all the real numbers except x should not be equals to n pi. The range will becomes here also all the real numbers. See here. The range will become all the real numbers here. Now we have to select here restricted domain. So we have to take, if you take minus pi by 2 to plus pi by 2, it will come minus pi by 2 to plus pi by 2 also, but better we in the for 0 to pi also it's coming. So we have to take here 0 to pi. For the different input we have the different outputs, so it will become a 1 function, so inverse will exist. So 0 to pi here, so the range will come r, all the real numbers will come. So cot inverse x domain will become here real numbers, and the range will become 0 to pi, open bracket 0 to pi, because it's the graph is not touching to the here 0 to pi. Pi is also it's not touching, for 0 also it's not touching, that's why. And what is the cot inverse x graph means? This is the cot inverse x graph. Okay, just understanding purpose I explained everything, but if you remember this much it's enough. Okay, sine inverse x domain and the ranges. Domain is minus 1, the close bracket minus 1 to 1, it's a minus pi by 2 to plus pi by 2. Cos inverse x is the domain of the sine inverse x and cos inverse x is the same, and the cosecant inverse secant inverse x is same. Tan inverse x and cot inverse x is domain is same, and the ranges are different here, you need to remember here. And the ranges of the sine inverse and the cosecant inverse x same, but here in the cosecant inverse we need to do the minus 0, and the secant inverse and the cos inverse same, but in the secant inverse you have to do the minus of pi by 2, and the range of tan inverse x and sine inverse x is same, but the thing is here close bracket, but here the open bracket. and the cos inverse x range and the cot inverse x range is same, but the thing is here close bracket, here the open bracket. Okay, just the range will come minus sine and cosecant and tan. It will come in between minus pi by 2 to plus pi by 2 only. Here close bracket, in the tan inverse it's a open bracket, and cosecant inverse x is minus of 0. You need to remember like this. And the range of the cos and the secant and the cot, it will come 0 to pi. The thing is, for the cos it's a close bracket and the cot is the open bracket, and the secant we have to do the minus pi by 2, minus pi by 2. And the real number, see here, tan inverse, cot inverse domain is all the real numbers will come. For the cosecant, secant also all the real numbers will come, except minus of the open bracket minus 1 to 1, here also minus 1 to, and the domain of the sine inverse and cos inverse is close bracket minus 1 to 1. Okay, just you write it on 3 to 4 times and use the tricks to how to remember some tricks if you applied. So just comparing the others with others like sine inverse and cos inverse, cosecant and secant, you will remember easily. Okay, and the range also in between minus, just remember minus pi by 2 to plus pi by 2 and 0 to pi, and sine, tan and cosecant, it will comes like same, only a little bit difference. You have to remember like this. Okay, it's very very important. Inverse trigonometry for the, so here the inverse trigonometric functions play an important role in the calculus. In the next upcoming days, you will study about the calculus. In the calculus, it's a very very important to know about the inverse trigonometric function. For this, they serve to define the many integrals. And the concept of inverse trigonometric function is also used in the science and engineering. Okay, that's the reason for the calculus, to study the calculus, it's a very very important to clear all the concepts of trigonometric functions and inverse trigonometric function both. Now we will solve some questions from the first exercise. Find the principal values of the following. Sine inverse of minus 1 by 2. Okay, let's. The exercise 2.1, the first question is find the principal value of the sine inverse of minus 1 by 2. So first we have to take here, let us consider sine inverse of minus 1 by 2 equals to y. Let us consider like this. You can take any variable. Okay. So next I will do here sine inverse, I will send it on right side. So minus 1 by 2 equals to sine of y. So I will write it here, sine y equals to here minus 1 by 2. We know the standard angles, sine of pi by 6. What is sine of pi by 6? It's a 1 by 2. We know this value. Okay, standard angles we should know. All the values of the trigonometric functions. So 1 by 2 means it's the sine pi by 6. Sine y equals to minus of sine pi by 6. This minus we need to remove here. So we will take inside the angle sine of minus pi by 6, because the sine of minus theta equals to minus sine theta. Okay, we should know all the formulas. No, sine y equals to sine of minus pi by 6. Sine get cancelled. Now y equals to here minus pi by 6. Okay. Now just check it this one. What is pi by 6? Pi by 6 means it is a minus 30 degree. Y equals to minus 30 degree. Is it in between the our range? Now see here, sine inverse x range is here minus pi by 2 to plus pi by 2. Minus pi by close bracket minus pi by 2 to plus pi by 2. This is our range of sine inverse x. Pi by 2 means what? It's a 90 degree. Minus 90 degree to plus 90 degree. So our answer come minus 30 degree. Is it come in between? Yes, it will come. So you can write it. Then therefore the principal value of the sine inverse of minus 1 by 2 is minus pi by 6. we know that the range of the principal value branch of sine inverse is, what is that one, where I wrote minus pi by 2 to close bracket minus pi by 2 to plus pi by 2. This is also important, close bracket open bracket also. Okay, therefore principal value of sine inverse of minus 1 by 2 is minus pi by 6. Okay, hope all of you understood this one. It's very simple. First we have to take the question equals to y, any one variable, then sine inverse you need to send this word sine y. So sine y equals to minus 1 by 2. You have to check it out, 1 by 2 where it will comes in the standard angles table. It is a sine pi by 6 value is 1 by 2. So minus as it is you need to keep here. So 1 by 2 equals to sine pi by 6. Then we have to take inside the angle this minus sign. So sine of minus theta equals to minus sine theta. Instead of minus sine theta I can write it sine of minus theta. So I wrote sine of minus theta. After that we need to check is it in between the our principal value branch. If it is s, you can write it directly. If it is not s, we have to make it in between the our range. Next question. So the next question here, find the principal value of cos inverse of root 3 by 2. Here also let us consider y equals to here cos inverse of root 3 by 2. Okay, cos inverse I will take it on left side. So it will become cos y equals to root 3 by 2. This value we know directly, it's a standard, one of the value of the standard directly. This is the cos pi by 6, because cos pi by 6 is root 3 by 2. You know this value. So left side you have to write as it is. Cos get cancelled, so y value will come here pi by 6. Okay. So we know that what is the range of cos inverse x, that is 0 to pi, close bracket 0 to pi. We know that range of the principal value branch of cos inverse x is close bracket 0 to pi. Okay, therefore 0 to pi means it is a 0 to 180 degree. So pi by 6 means it is a 30 degree. Is it come in between 0 to 180? Yes. So therefore principal value of cos inverse of root 3 by 2 is pi by 6. Okay, some of the students will solve till here and they will leave that. Don't do like that, complete it. Okay, we have to, the next step is we need to check is it in between the range of that particular inverse function or not. After that only you have to write the principal value of cos inverse of root 3 by 2 is pi by 6. And then this is the final, you need to complete, you have to complete this one. Don't do hurry. And then in the next video we'll solve the remaining questions. Still you didn't subscribe the channel means please subscribe the channel and share the videos to your friends for the more videos. Thank you so much.